So let's do a brief intermezzo on how to do OLS with our data. And basically we're going to do it with just one data set out of the 10,000 before we start looping over it and doing it 10,000 times as we do in the notebook. So to get the first idea of the data that we have generated, we can plot it. So we can say we do a scatter. So we have our simulated X data. So we're not going to look at all 10,000 of these, but we're going to just look at the first one, which has in Python index 0. And then in terms of the samples, we want to look at all 20 observations. So that's why we have the colon here. And we have simulated Y. Here also we choose the first out of the 10,000 cases that we have generated. And also here we want to see all 20 observations. Yeah, so we can have then X label, which in this case would simply be X. And similarly we have a Y label, which would simply be Y. Yeah, so this is what our data looks like. So the data is generated for X values roughly between -2 and +2. And we have this negative relationship, so that's basically the slope that we specified between X and Y. So now how can we figure out what the OLS line is for this data set of 20 observations? Well, a number of ways to do that. Here we're going to basically use stats models. If you want to understand the syntax of stat models, simply go to their website. So Google Python stats models. You don't actually need to know this for this course, because we're not the course isn't focused on stats models. But here I need a sort of quick and dirty way to get to an OLS. So again, I'm specifying the first out of the 10,000 rows, and I have 20 observations. I'm going to specify this numpy thing, just to show you quickly why I do that. So when you look at TensorFlow, random, let's say normal, yeah, the result of this doesn't look particularly nice because it has all this stuff about tensor and the shape and the type. So stats models cannot deal with that, but then we can apply the numpy method on this, and now it looks like a normal numpy array. Yeah, so that's what we're using here. Then in stat models there is a function to add the constant, and next to the constant we have simulated X. Again, we're using the first of the 10,000, but I want to have all 20 samples generated from X. So there's one set of brackets, and that's the second set of brackets. So we should be done, is it? Yeah, so I don't need this one. Oh, the thing that I forgot here actually is again to use numpy. And then we say model fit, and we want to know the parameters. So what do we get? So when we specify this, so we basically say fit the model. So that's what the fit method does here. And then I want to have out of that thing that gives me lots of information, but I simply want to have the parameters here. And the parameters are of the first one is close to 0, and the second one is around -2. So if you go back to the way we generated data, you will see that this one is the slope, and this one is the constant. So just to check what this actually gave us, let's copy this over here, and now the thing I want to do is I want to plot the regression line that we just calculated. So for plot I need to specify a set of x coordinates and then a list with y coordinates. So since the OLS result that we have is actually a line, I only need 2 observations for x and 2 observations for y to actually plot that line. So I need one step before this, so I actually want to have these parameters, so I'll call that params is model dot fit params. So my line is going to be the constant, which is the first one in this array, so it has index 0, plus the slope, which is the second element, which has index 1, times -2, so that's my first y coordinate corresponding to this x coordinate of -2. And then I can copy this. And for the second one I have +2. Yes, I have 2 x coordinates, -2 and 2, and on the OLS line that corresponds to this coordinate for y, corresponds to the -2, and the second, this one, corresponds to +2. So I can run this, and you can see that indeed this looks like it's the OLS line, so the shortest distance through all these different points that we see in the scatter. So as you may remember, the slope that we specified in our data was exactly -2, but because I only have 20 observations out of the data that we generated, so I have a sample of 20, the slope that we find is not exactly -2, so it's -2.1 if I can summarize it a bit more simply. And the thing that I'm interested in is how does this slope vary across the 10,000 different data sets that we have generated. So that gives me a sense of the distribution of the slope.